The background. Based on the foreign situation, we have to learn. Today, in the world, people facing serious energy security and environmental problems. Fossil energy increasingly exhausted. Previously, kind of energy developed is limited, such as thermal power, hydropower. So, in China, for example, requires establish and improve of green, low carbon, and environmental circular economic system, structure of clean, low carbon, safe, and efficient energy system. There are national strategic goals. In 2030, will be reach peak carbon dioxide emissions. And in 2016, achieving carbon neutral, it's also meet with the Paris Agreement. Its goal in 2020 was reached non-fossil energy 20%. And in 2013 will be in 25%. So its urgence of alternative energy is very necessary. Learning new energy like solar, wind will face such problems. We know they are randomness, the unpredictable, it means intermittence, the uncontinuously, and uncontrolled generating capacity to be limited are caused by above reason. Therefore, our research significance for large-scale PV plant and ecological restoration is located at, we know, some countries with higher land desertification, but rich in solar or wind resource. They not only need clean energy urgently, but also have demand for desertification control as well. Promoting development of PV industry plus ecological restoration can be better for mutual benefit and win-win. So that is important for sustainable development and to build a community with shared future for mankind. Okay, let's see the next part. The part 2 is a relationship between PV development and ecological environment. Here we see has analysis of PV development and ecological environment impact. There are 3 elements. First is climate element, the microclimate regulation in power station farmer. The second is soil factors, the regulation of water and soil function in power station farmer. The third is the vegetation factors, vegetation restoration in power station farmer. So the PV array can convert part of solar energy into electric energy, so that has changed local surface energy distribution. Even expansion of scale, it's necessary to study ecological elements of local and surrounding areas. Here are the analysis from 2 visions as first, the qualitative judgment. The second is a quantitative study. So that's improve the quality of the regional economic environment based on requirement of eco-friendly development. In construction, quantitative research on ecological environmental effect, exploration and research on how to ensure win-win between the maintaining ecological basic function and the use of solar resources. This is also the social responsibility of enterprises need to perform and the key problem to be solved. You see next, the PV power plant plus desertification control. The right side is the built PV power station in largest scale. The left side is the eco-friendly environment of vegetation restoration. The vegetation recover suppressed dust, even dust storm. The suppressed dust PV array arrangement modules shaded surface so that the suppressed dust goes up. In addition, reduce hotspot effect, increase power generation, and add more service life of module. The humidity rise may be with more rain and keeping humidity between module and the ground as well for soil moisture and vegetation recover. The temperature drop has reduced evaporation of water, keep wear of grass and brushwood recover, slow down wind speed on the ground, and good for sand stabilization. The vegetation recover and sand fix for long period as good for PV blanket stabilization, improve reliability and tracking system, and reduce maintenance costs. This is a virtual cycling win-win situation. This shows analysis is a comparison for longitudinal comparison of satellite remote sensor data. We see that from 2012 to the 28, since 2030, construction of PV power station has increased year by year. And the improved effect of ecological environment has been gradually reflected. We see from 2013 and 2014, we installed more solar panels, and 2015 and 2016 up to 2017, 2018. The sand area has been limited. Also, the land almost been covered. So obviously, big change. For horizontal comparison of measured data analysis, we see right side, the comparison of wind direction in the field with out of field. The variation in the wind speed and direction, we see the curve, wind speed comparison. According to the statistical data, the monthly maximum wind speed in the field is 30.4%, lower than that out of the field. We see the curve from up to the down. The research finding, the conclusion is that first, the regional ecological environment has become gradually apparent and vegetation coverage is a gradual increase. The second, have changed the local climate, especially reduced wind speed and increased air humidity. In addition, the regional soil nutrient content has changed obviously, and the soil fertility has been greatly improved. The PV power plant has improved their power generation and equipment safety and stability, which has formed a win-win situation of development. The last is on ecological environment, combining with the research method and provide technical support for decision making for optimize to managing PV industry park. Let's see the left picture. The first is original landform is desert area like this. Yes, through the vegetation restoration and to coordinate the development, finally become very beautiful green. Here is the application of Agri plus PV complementary power station. Agricultural plus PV complementation farm This is one type of production structure. Just a project of installing PV module on existing agricultural and forestry facilities or breeding greenhouse. See the photo downside, the picture, the outdoor agri plus PV complementation. And middle is indoor greenhouse type, the agri plus PV complementation. The last is agri plus fishing plus PV complementation. This project, be interested. Yeah? This is an ecological environment change trend of agro PV complementary power station. You see the picture outdoor, the original landform in the desert area. We have installed the PV power station. And the middle, this picture is the crop to plant start. The last is a crop grown and changed original desert land. The downside is also outdoor PV greenhouse, crop have a forest, the original land. And last one is agro PV complementation, change trend of green and sparse land. Such farmer change to more green and beautiful. What is the advantage? The application significance of agro plus PV complementary power station first protect the ecological environment, turn the desert into a cropland. The improved land utilization rate, the PV is built in the upper part and the crops are planted in the lower part. Increase economic benefits. The desert turns west into Trojan and crop increase economic benefits. The last is a reduce investment cost, and it can create employment. We see the downside of the picture, the chicken farmer, very interesting. The part 3, this large-scale PV power station plus ecological restoration application. These application cases. Let's see the case of in Qinghai PV power station in plus desertification control. Let's see the right map. It's China ecological protection showing. The left shows our province Qinghai. Our company HHDC located. Involving the ecological barrier of Qinghai Tibet Plateau in 2 barriers and 3 belts, and play a very important role in construction of China ecological security strategic plan. The covering almost all the most typical frontier ecoregion, such as grassland degraded area, the source area of 3 rivers, desert and desertification area, the farming, pastoral, ecotone, even the mineral exploration area. The Qinghai is a typical ecological, the frontier area, but this region is China's solar energy resource rich region. It's the largest base of PV power generation, most built by our company, HHDC. The coordinating the relationship between PV development and ecological environment protection is the major issue. So we see the downside the 2 picture. This is the Haixi, the power generation base, and this is also the Hainan power generation base. Now it's more than 8 gigawatt PV station there. What is the cause of grassland degradation in Qinghai, Tibet, Plantum, present situation of ecological environment? Due to the joint influence of global warming and human activities, grassland degradation, especially in the hinterland of the Plantum. The climate warming and desiccating temperature and precipitation are the main factors in climate change. Affected by global change, the temperature of Qinghai Tibet Plantum generally shows a rapid upward trend. Rainfall increase in the winter and speed, but decrease in the summer and autumn. The change of the seasonal distribution of rainfall leads to obviously drought in grassland. Climate warming and desiccating provide internal dynamic conditions for Plantum grassland degradation. The harm of rodents, the Plantum pica, we call this toka, the rats, have very high bleeding rate in degradation grassland. Do you see this picture, the third picture? And this overglands, the seasonal river become less water very seriously. The overglands, according to the statistic data, the overglands rat in Qinghai and Tibet are 16% and 78%, with an average of 45%. The latest scientific research result shown that the decrease of total nitrogen content and the imbalance of nutrient flora caused by overglands and exporter livestock products are the main reason for degradation of grassland in Qinghai Tibet Plantum. The man-made unreasonable interference, the unreasonable human activity, including grassland, reclamation, road construction, mining, and sand excavation. In addition, in order to find medicine, the cold-tap synthesis called a local herdsman dig out complete turf and cut down shrubs. Those activities are very harmful to grassland. We see the picture of a plants. You see that the land we talk is a black soil beach, the construction mold. Let's see the desertification control result. There is temperature and humidity comparison. The temperature comparison in the first, second, and third quarter, for example, in 2019, the temperature in PV park was 0.74 degree, 0.26 and 0.23 degree lower than in the off-field control area. So large-scale PV construction has certain temperature effect. The humidity comparison, we can see the curve in the first, second, and third quarter. The air humidity in the PV park was 4.96 and 2.26 and 0.9% higher than in the off-field control area. So large-scale PV development can increase local air humidity. This also, the desertification control results, we see the curve before and after establishment of station, vegetation coverage in the park increased significantly, mainly in June and August, with the growth rate of 15%. With the commissioning of the power station, the vegetation improvement effect was significant. We see the curve. The blue one is before the station is built. The brown is after station is built. It's very, very. So let's see. This is another case showing Ningxia. This is one province in China. Ningxia, agro plus PV complementary project on the picture, the largest scale. Also, the ecological resources such as wetlands, lakes are rich, and even more desert area in the Ningxia. Ningxia has one kind of plant called lithium beryllium, high quality, and the plant and PV power project has been formed agro plus PV complementary production. In the cooperative business model of enterprise plus farm is adopted. The enterprises are responsible for investing, the seedling, planting, purchasing, processing, and selling. The farmers work for daily field management and picking of land at zero cost. They are hired and become both industry workers and business owners. This region has world's largest agro PV complementary project in desert area. Planting lithium beryllium and PV modules can create 80,000 jobs. The desert area will turn to green more and more. See the next photo. This photo shows us Ningxia agricultural and PV complementary project. The first is a primitive desert land for original land. They start construction, and this during the construction, the 30 is planted lithium beryllium. This are called, I talked with this one. This is one medicine, also one fruit. The last one and the environmental change after complete of PV power station. Nice, very beautiful. The part 4, the method of desertification control application method. We know the traditional method. We see the picture. This is the strong grid and the sand blocking fence they put there. Anyhow, can't change the sand natural, only for sand stabilization. Effect is not durable. The laying, the chemical, you see, the chemical cementing materials on the surface to fixing, it is great negative impact on environmental and high cost. The downside picture of biologic planting Salix samophilia, the tree, the green small tree, and use aerial seeding. However, it's very difficult for growing of vegetation in this area. So the right side, we see the soil self-repairing and self-regulating. The ecological mechanic properties of soil are self-repairing and self-regulating. The failure and fracture of self-repairing soil and soil state can be recovered in ecological state. No matter how, the arrangement of self-regulating soil particles changes. There are always adhesion between them. Anyway, this water here, water raining must behave. It's a life of all. We see this desert solarization method. It means that makes sense to the soil. The technical principle is the binding force on sand particles and enable them to have functions of self-repair and self-regulation, similar to the soil. It has function of contain water, nutrient, and air, become a good carrier for plant growth. Implementation, binding material plus water, and the ODI binding and adhesive binding. This is binding mechanism. We see the picture here, they are only a sand form, and after the solarization, moisture, and fertilizer conservation. Here is after solarization, ecological state. This is self-repair and self-regulation state. After solarization, the microstructure of sand like this. Finally, they use it to plant. Here also are application cases. The large-scale planting experiment of 4,000 mu, equal to 217 hectares in Ulaanbaatar Desert. They are Alashan Liga in China. They are in near Mongolay. Yeah, success only with 6 months. We see the picture before the transformation in general. For example, in 2017, this during transformation in April and during transformation in May, in July, they are plant. Yeah, you see in this plant, and after transformation, or in August, it become green. After transformation in September, total is green, become green. In 1 year, it's successful. Here has more application cases. For example, this is in Xinjiang. Taklamakan Desert, this is the biggest desert in China. Their plant now is become green grassland, some area. This Sichuan desertification, this through the ecological restoration, they become grasslands. Before it's also desert area. This is in Tibet. Yeah, this also through the ecological restoration, the plant now green and flow. We see the downside, UAE. In Abu Dhabi, now they are use their greenhouse to plant the vegetable for sale to market. The last one, and in Africa, Niger, the Sahara Desert. The Chinese farmer help them to plant in the greenhouse for the vegetable to sell market. This also, for example, in the UAE, desertification control. Before original is the desert mountain here. Now the Dubai, the picture is very beautiful now, is good city. For example, before the UAE, the United Arab Emirates covers an area of 83,600 square kilometers, and the capital, Abu Dhabi, covers an area of about 67,300 square kilometers. Approximately 85% land in Abu Dhabi is classified as desertification. Here is a case of scientific research did by a Chinese professor. The Chinese professor Yi Zhijian, his research team from Chongqing Jiaotong University has studied, which has fully verified the feasibility of desert solarization. However, they are trying to plant grass, vegetables, and shrubs within the extent of about 10 square kilometers in Abu Dhabi. Let's see the result of desertification control there. The effect of sand stabilization is remarkable. The plant roots are spread all over the soil land layer and deep in the sand layer. You see the picture? This is sand layer, orange. This is a soil layer. They also become from sand to the soil. The root is deep grown. So the biologic crust can be rapidly formed in 1 and 2 years, and the soil forming effect of sand with plant decay turned into green manure can be continuously strengthened, and the quality level of land can be continuously improved. After planting for 1 year, the microbial population of quantity reached or exceeded the control soil samples. So the effect of solarization is remarkable. In this photo, we see some photo. This I did last week in Dubai. Now this Dubai city is already green and tree is grown. We see they plant the flower, the grass. They use the pipe. You see the pipe. This pipe is they use this drop irrigation technology. So all over they are use this one for the water irrigation. So from this picture, we send this after 1 year. This is 1 year. The sand turned to the soil like this form. So this is a new plant. I see this sand, original sand. They are just put the flower here. After maybe 1 year or 2 years, the sand will be turned to the soil and all the color, the green. Ecological, this shows this picture, ecological restoration impact based on large-scale PV power station. With the complete of PV power station, the wind speed and the evaporation decreased. The green ring gradually improved. We see the picture, the green ring around the PV panel, around PV station. The ground become green now due to the sand solarization technology. So that's ecological protection by large-scale PV power station have been greatly improved. Let's see the part 5. A prospect of PV power station plus ecological restoration in African countries. We know June 17th is the World Day to combat desertification and drought. The theme of China in 2020 is join hands to control desertification, protecting green air and clean water. In Africa, the biggest desert, Sahara Desert in Africa, surrounding area are the drifting desert. Under action of the direction wind, the drifting desert will continue to migrate along the wind direction. Whenever there are opportunities, the yellow sand driven by wind will devour the roads and buildings. The global desertification area has reached 36 million square kilometers, representing 1/4 of the Earth's land area. Desertification is a major environmental problem facing the world, seriously strengthening ecological security and sustainable development. Facing this worldwide stubborn disease we call the Earth cancer, how can effectively control desertification? How to effectively carry out global economic restoration? So a scheme we saw. The PV power plant plus ecological restoration be effectively applied in African countries. This is the feasibility study. We see the solar resource map in Mina. Yeah, this is Mina. We saw the horizontal irradiation. Yeah, in this red area is more sun. The North Africa and the Middle East region is rich in solar resource. That's suitable for construction of PV power plants for us. The desertification is severe in the Africa area. The PV power station can effectively block drifting of desert. It's possible to set up Agri plus PV complementation project through technical manner. So, however, an eco-friendly land can be built through PV power station plus ecological restoration. The feasibility study, there are three aspects. The first is a PV construction. The conditions permit development of large-scale PV power station in African countries. They may have made great effort to develop a PV power station. Second, a large-scale PV power station drive construction to ecological civilization. The conditions permit the PV development in African countries. The second, development of agricultural and animal husbandry. The benefit of application of large-scale agri plus PV complementary power station in African countries. African countries can produce and sell green fruits and vegetables. Self-supply and self-sufficiency of farming and animal husbandry. The economic benefits brought by agricultural produce reduce the cost of the PV power station. The last, ecological restoration. To protect and improve our living environment, we must protect improve our ecological environment. A good ecological environment is the most inclusive welfare for people's livelihood. The protecting ecological environment means protecting productivity. The ecological environment management is a systematic project. The protecting ecological environment is priceless. So, the PV power station plus sand control plus agricultural planting, the developing green sustainable energy in African countries. The fruits and vegetables, the desert planting have been supplied. The beauty glass pasture provider desert sheep, we call that a photovoltaic sheep. You see downside. They are known in our company, in China, SPIC and HHDC. So the prospect, a dream comes true. So this subject, that's all. Thank you. Following, I will to share the brief introduction of the company SPIC HHDC. Let me first close the PPT. I have to change in this one. Have you seen this file?
Yes, yes.
Okay, thank you. Thank you. This is a brief introduction of company overview by HHDC, SPIC Huanghe Hydropower Development Corporation Limited. Total energy capacity is 27.51 gigawatt now. The total asset US dollar 25 billion US dollar. HHDC is a top energy company under the SPIC that established in October 1999. It focuses on the development, construction, the operating and maintenance of power stations, including hydro, photovoltaic, wind, green hydrogen, integrated smart energy, as well as the thermal power business. HHDC also owns some mineral assets. Here are the highlights. The HHDC has hydropower 11.54 gigawatts, The solar is more than 8 gigawatt, wind has 5 gigawatt, and thermal power has 2.62 gigawatt. The renewable energy share 19.48%. The world's largest hydro-solar hybrid power plant. It has 17 hydropower stations and 15 plus PV stations in operation, and 1.5 gigawatt PV demonstration base under construction. The 20 gigawatt renewable energy base plan for next 5 years. Here is a balanced vertical integration of PV industrial structure. The HHDC has formed a complete industry chain as a polysilicon, the Wi-Fi, cell, modules, a PV power plant system integration, and construction and development of PV power station. We see the picture, the photovoltaic industry chain. They have polysilicon, the Wi-Fi, solar cell, and solar module photovoltaic generation. The HHDC manufacturing sector has reached the world-leading level with high efficiency N-PERT plus TOPCon and IBC Tech. Mass-produced products mainly for domestic market and quickly expanding in the international market. HHDC built the first 200 megawatt N-type IBC cell and module project in China, with the large capacity and conversion efficiency greater than 23% is high. Here is a large, the world's leading hydro-solar hybrid power generation technology. The HHDC owns the world's largest 815 megawatt hydro-solar hybrid power plant and obtained a national patent for this technology. Through the hydro-solar hybrid coordination control technology, solar power is converted into virtual hydropower to tackle the problem of randomness, fluctuation, and intermittence of solar power. We see the picture here is the 850 megawatt power PV power station here located. This through the transmission line around 40 kilometers to the hydropower dam, the control center, to get connected. The HHDC owns the 100 megawatt national solar power demonstration base, which was developed and constructed all by itself, including 6 test areas for 10 module, inventor, mounting structure type, new technology, and new products from well-known domestic and international PV manufacturers. Design comparison, comprehensive comparison, and energy storage comparison to provide the PV and energy storage application design verification, material aging and reliability study, system proof and comparison, the power output rationalization, etc. It's a world's largest fair test project and operation, with the cooperation of Fraunhofer from Germany and Dober from US as the strategic partner. The focal program for international development and partnership, the international power investment, hydropower, PV plus, green hydrogen, integrated smart energy, and other renewable power generation investment, which is a major intention of focus mission. The engineering and technology services, the solar power, hybrid power, energy storage power system design and consulting, the hydropower, solar power project, construction management, O&M, and technical services, providing integrated intelligent power solutions. The module providing customized differentiation, upmarketing, high quality and high efficiency PV modules, including PERC and N-PERC plus top core and N-type IBC. So my introduction to the end. Thank you. Thank you very much.
Thank you very much, Mr. Liu. This is a very wonderful presentation and very good lesson for the participants. Yeah, very excellent presentation, and the content is also excellent. It gives us really kind of eye-opening information on how you could transform the desert into a green area. So there have been some questions on the Q&A section. I will maybe give you a few of them, and then later on I'll give the floor to 2 or 3 people who have raised their hand who also want to have some clarification. So maybe I will combine some of the questions because they may be related. So there's one who is curious to know how is it possible to change a drought affected by a drought affected area to green area if there is no access of water sources like river or other natural water sources. If we are using groundwater, how feasible is it to use the technology? So that's a question which is also related to other questions. Maybe the second one that I want to put forward is, does the shading from the solar panels affect the growth of fruits and vegetables? That's the second question. There's another question, actually, who is asking a very technical question about the height of the panel, of the solar panel. So that's what I mean. This question is related to the previous one. Actually, she's asking about the height of the panel so that people can develop agriculture or farming or growing cattle or animals around it. So what could be the good size of the panel? So yeah, maybe we start with this few question. After this one, maybe we can also give the floor to some other colleagues who have raised their hand. So Mr. Liu, if you can just highlight on these ones, then we move to the next set of questions. Thank you so much.
Okay, Mr. Koba. Let me to answer this first question for the water supply to some drought areas. Of course, this is a big issues. Anyway, in the dry area and in the sand, the desert area, we can put the PV, the large scale PV plant, but depend on for the plant, to agro plus PV, so depend on this resource of the water. Must have the water. They dig. I know some place they dig. Even I to some country to investigate. So some place they are forced to find the underground water for to take the underground water and to change the area. Use its water to plant and plus the PV to agricultural some idea. But this will start this now. It's not so in this time. Is we try in some area. Must have to take the more feasibility study like this. So this is first question. The next question is for this said for PV station, the high, the more we in China we have experience. If some place like our company, they are in some place put the PV station to set up the PV station. Some animal husbandry to there. We care some sheep, so we will care think about the grass grown enough to hide the distance from the ground. It should be half. So the grass even very grown, and in the dry season, maybe in the winter, the very careful for the fire protection like this. But it can be done in this area. We use this one. So my question is that.
Yes, I think you addressed them very well. Thank you so much for that. So now I'll give the floor to maybe two people, because we have not many time for this session. Mr. Abdul Kadir Ibrahim, I see your hand is raised. Can you take the floor and put forward your question? Abdul Kadir Ibrahim.
Hello, can you hear me?
Yes,
Hello?
yes,
Okay.
please.
Yeah, thank you very much for the presentation. It was an elaborate one, and you really talked much about our region, Africa, and how desertification is affecting our livelihood. But I work in Energy Commission of Nigeria, and I've been in renewable energy department for a long time, and I've had postgraduate courses on renewable energy, especially the PV system. You know, in the desert area, if you're talking about installation of solar PV for maximum power generation, because of the effect of heat in that area, is the company you have advertised, I've forgotten the name, are they taking cognizance on how, in their production of PV system, did they take cognizance on how the effect of the heat that is coming from that area have a minimal effect on the PV output generation? Thank you.
Okay, I get your problem. I know. You have provided these technical issues.
Yes, sorry.
Yes.
Mr. Liu, sorry. Let me take two more questions, then you can answer the question together. Okay?
Okay.
Yeah, it's better so that we can save some time. Thank you, Mr. Abubakar. Let me ask now Mr. Abdul Kadir. Sorry, Abdul Kadir Ibrahim.
Yes, thank you.
Yeah, thank you so much. Now, Mr. Mamadou Lamin Ba, please take the floor and put forward your question. Mr. Mamadou Lamin Ba. Mr. Mamadou Lamin Ba. Mamadou Lamin Ba, we cannot hear you. Can you put your question? Mr. Ba, we cannot hear you. Okay. Let me ask then the next one. Mr. Oseni Adebayo.
Good morning, sir.
Good morning.
Yeah, thanks for the presentation. Very, very nice, insightful, and educating indeed. Especially when you made mention of the Africa aspect. We really, really appreciate. But my question is this: all these PV mounting installation, don't you think it has negative concern the photosynthesis of the plant? Does it have a negative, or is there any effect concern the oxygen and carbon dioxide? As we know that photosynthesis is the method of production of the plant, is there any negative effect towards the oxygen production and carbon dioxide during the photosynthesis? Thanks so much, sir.
Okay, thank you very much. Mr. Abdullahi Adebayo. Mr. Abdullahi Adebayo, can you?
Yeah, I can hear you. Good morning, sir.
Good morning.
Yeah, this is Abdullahi Adebayo from Nigeria. I really appreciate the presentation and the organizers for this wonderful training. I love to be here. My question is this: like in Africa, the company that the presenters talked about, do they put in place the acceptance of the solar energy system in Africa concerning the level of illiteracy in this place? And also the instrumental payments of energy system in Africa is very low and is not really acceptable by generality of the people. What are they doing about that? And secondly, there are a lot of unawareness about the renewable energy system in this part of the world. And we as engineers, we are greatly aware of that. Unlike in Europe, America, and other places, where everybody is aware about the changing of the ecosystem friendliness. What are they doing about educating the African engineers about diversification into absolute renewable energy system? Thank you.
Okay, thank you so much. Let's give the floor to Mr. Liu now to address these questions. Yeah, Mr. Liu, you have the floor.
Yes. Yes, Mr. Thank you for your question. For this question, for three questions, first, he talked about the heating, the high heating, the radiation, the effect for the PV module, even effect of the generation. This is true. We are our company now. We study, continue. We study in the different area. We are to learn. We are to learn. We are to record their data. We will to know which place has a radiation. How is the cover go to the tender? This need longer to calculation and to study. So after that, we will to know in which place has a more heating, the effect. So this place, how to put the proper, the suitable PV module. Like this, we are studying on the way. This is the first question. The second question is for negative. Yeah, sure. I saw this also agro or PV scaling, PV power station, all the advantage, but has some negative, maybe depend on the area, the environment, even some place need some land, acquired some land, and also infect some local people's living soil, like this also. For the negative, we are dependent on the different project. We will to see if you have to implement some project in some place. We have detail to study this, to take this feasibility study for to remove the negative, or we are taking this positive things for to improve your project like this. For last question, I don't think so. This education, so I know in the Africa, some country, Nigeria, there's a low education. Even their profession, like this PV, like this high the solar, this education contents will be low. So sure, I'm sure. So I need to give some young people, to give some school, some university, to erect some organization to push the education to learn, let them to learn, to know, to hire to know this knowledge for the improve. This needs some time, so some years to my thinking like this. Okay, thank you very much.
Okay, thank you very much. Maybe last one, because I saw one question raising about the company, because you also presented the company. So there's this guy who said the company, is it a private company you are having, or is it a state-owned company? How is the I see you talk about the installation capacity of the company, but is it state-owned or is it a private company, and how the investment model or the business model of the company is? But also, in adding to the question that the colleague raised about how to educate the engineers, you know, at AFREC, we are currently working on a very comprehensive capacity building program that will assess the skills gap in the sector, and what's measure that we need to take to improve the skill, to enhance the skill of African engineers, technicians, even decision makers. So we are working on that program. Hopefully by mid of next year, we will have a very comprehensive program that we will be supporting our member state and country to implement them and to support them. But now, personally, I think that the main issue is not really that we don't have good universities or good schools that teach the good fundamentals of different sectors in Africa. But personally, I think that what we are lacking is the opportunity to give to our young people to apply or to do the work on the ground. So I don't know which kind of maybe moving forward, which kind of cooperation we can have, like okay, do a very small scale demonstration project for maybe 1 week or 2 weeks. One would go in one place, we install PV solar and see how it work, and really teach them how to do the job. For me, I think that is what's missing. Maybe we can discuss how further discussion, how we can collaborate with AFREC, with the China Renewable Energy Engineering Institute, how to really to provide some of the practical training to our young people. So with that, you can comment on that, and we really thank you very, very much for the good job that you are doing, and also for the good, excellent presentation that you have made. Thank you.
Oh,
Yeah,
okay.
you can go ahead.
Oh, thank you very much, Mr. Yagoba. SPIC and HHDC is a state-owned company. The SPIC is in China. In China, there is SPIC have 5 large group company. So HHDC is under the SPIC. Is a state-owned company. So this is sure. And for your communication, for the next how to we are joined together, we are doing this program is for the after we will to communication. We will to consider some program for the education, even for the education for the young people to training. So even one can exchange our experience. You can send your organization people to China, our company to see, and our company's people also some skilled people, some engineers can to communication with you. This is normally this is our this program is focused for this region. Okay. Mm.
Okay, thank you so much, and that is a very, very, I think, important milestone for our participant. And once again, I thank you very, very much. I know that there are many people who want to ask some important questions, but unfortunately, we have to move to the next presentation. Actually, the next presentation is also from the same company. So. But this presentation will hopefully be focusing on photovoltaic and the storage system. I know yesterday there was a lot of questions about the storage system, and there's at the end of the third presentation there was this question about if also we can have a kind of a storage for hydropower plants. So, but that question was not answered, but I hope that the next presenter, who is Madame Kun Zheng, who will be enlightening us on the photovoltaic and energy storage practical training. So let's pay attention to the presentation of Madame Kun Zheng. You have the floor, please, Madame.
Thank you, Mr. Yagoba. Good morning and bonjour, everyone. I'm really honored to have this opportunity to communicate with you and share some of our company's achievements. My colleague, Mr. Liu, have already introduced our company, because we are state-owned company and we are just having rich experience in the renewable investment development. And you can see that from now, our company's installed capacity is about 27.51 gigawatts. We have like 8.36 gigawatts of PV, and we have 4.99 gigawatts of wind power. And now we also have some energy storage plants in Qinghai and in Daqing, the two cities in China. And we have rich experience in this. And based on the effort for so many years, we are very competitive in the photovoltaic monitoring, power station operation, and power station design and construction, and also the O&M of the power stations. Which bring us the topic today, the solar PV energy storage in practical test platform that we built in China. So maybe now I will share my screen with you. Okay. So the topic of today is solar PV energy storage in practical test from that HHGC built in China. So my presentation divided into 4 parts. The first part is the research background of this platform. The second part is the innovative research that we did on this platform. And the third part is the achievements that we got. And we want to share with you some of our achievements and some of our experiences. And last part is the future perspective. That we want to explore that what we do that in the cooperation with the African Union countries, that how we can offer our technology and some of our talents. So let's move to the first part. The first part is the research background. So we are living in an area of rapid technological development, and the photovoltaic technology is also changing rapidly day by day. But at that time, which about 2015, the rapid development of new equipment and materials are mainly from laboratorical analysis and evaluation, lacking the means and methods of outdoor empirical testing and analysis. So for the key equipment of large grid-connected photovoltaic PV generation system, the instrument methods, accuracy, actual operation performance evaluation methods, and the equipment layout schemes required for their online operation testing and measurement are still under study. So, and the data comparison and analysis and also the actual operation performance evaluation methods are simple and cannot be significantly and effectively evaluated for the complete photovoltaic power plants. So by building this platform, it can provide a scientific data support for new technologies, new products, for the global development of the industrial policies and the technical standards, which can provide a scientific basis which can promote the technical process of the photovoltaic industry. Industrial development is of great significance. So that's why we build this platform. So the significance of this platform, the first one is facilitating the construction of demonstration area for comprehensive application of renewable energy and energy storage. So we all know that the renewable energy is great and it's green and it's have many advantages, but it also has some disadvantages. It's not very steady. So at this time, so we need to have some backup methods to fix this problem. And now we come up with the energy storage. So this platform also can facilitating the transformation and development of the energy resource-oriented cities. So like Qinghai province, which our company located, we have rich solar resources and many desert lands, so which are resource-oriented cities are many suitable for this kind of platform to be built. And the third part is the accelerating the reduction of tariffs of new energies. So we can see that by more new technologies, and it's just an evaluation, and we can just reduce the tariffs. It's also a good part. The fourth is facilitating the construction of impractical test area under the innovative development modes of new energies. The fifth part is facilitating the impractical test of new technologies and products. And the last significance is it can facilitate research on the demonstration effects on PV and ecological protection, PV and energy storage integrations. So like my colleague Mr. Liu had mentioned, so this PV plant and the energy storage plant, they can also have some ecological protection and the advantages on this. So you can see on the pictures that he shared. So at first, our PV plant is like a desert. There are no people living there and no animals there. But when we build the PV plant there, and it can have they change the weather. It can more moisturizer and the water and the grass have grown, and we even have sheep in there. So this is new methods for the PV plant, PV and plus the ecological protections. So that is a good part for the PV plant. And we also can having the PV and energy storage integration to fix the problem that the PV power stations have the unstable problems. So let's move to the part 2. So the innovative research.
Sorry, can you put in presentation mode?
A presentation mode? You can see my slides?
No, I can see, but it's smaller.
Oh, okay. Oh, sorry about that.
Yeah.
Is that good?
Yes, this is perfect. Yeah.
Okay, thank you.
You're welcome.
And the second part is the innovative research. So this is our first 100 megawatts level photovoltaic in practical test base. It's located in Qinghai province, northwest of China. And in this test base, we have an integrated test base. So we can have we divide it into different parts and to see and compare its different equipments and see which one is better. For the first part is the inverter. We can see that we have inverter comparison area and the module comparison area, design comparison area, mounting structure comparison area, and the overall performance comparison area, and the energy storage comparison area. So this is the world's largest 100 megawatts level outdoor in practical test base. In this test base, we have 148 mainstream PV technologies and products compared on the same platform. So in this module comparison area, there are a total of 23 sub-areas with capacity of 26.76 megawatts. It's covering 23 different kinds of modules from 12 module manufacturers. We have P-type crystalline silicon modules and PERC modules, also a variety of N-type high-efficiency modules such as HIT, IBC, and bifacial modules, and two kinds of thin film modules like CIGS modules are equipped. And moreover, a module cleaning comparison area is designed to analyze the impact of cleaning frequency on this power generating performance of modules. It's also important part for the PV plant. To test the performance of these cleaning products, and we can see that this part is the mounting structure area. So in this area, we have a total of 13 sub-areas, which capacity of 14 megawatts, covering 17 different types of mounting structures from 6 manufacturers. This area is used to compare and analyze the operation status, OIM cost, power generation, and comprehensive investment returns of different types of mounting structures. We have like fixed mounting structures, seasonally adjustable mounting structures, and flight single axis mounting structures, and the vertical single axis and a dual axis mounting structures. So for the inverter comparison area, we have 30 megawatts of this the capacity, and we have 21 different kinds of inverters from 30 manufacturers. This area is for the comparison and analysis of long-term integrated efficiency, power generating performance, and failure rate of the mainstream inverters. We have centralized inverters, central distributed inverters, string type inverters, and the particle new type liquid cooled inverters, and supplying demonstration technical data for inverter selections in different conditions and the geography. So on this part, this is the design comparison area. We have the capacity is about 33 megawatts. We have 11 design comparison sub-areas and two reference comparison sub-areas. We have optical DC side capacity radio design, current collection scheme change, module mismatch pack comparison, module layout and wearing methods comparison, impact of module numbers in series on PV generations, cable section selection comparison, and voltage level optical sub-area capacity. All sub-areas are compared with two reference sub-areas to analyze the characteristics of different designs. So in this area, and for the energy storage area in this part, this is about the capacity of this area is about 20 megawatts. We have energy storage system of 16 megawatts hour including distributed DC energy storage of 8 MWh and centralized energy storage of 8 MWh. This area is used to analyze the different power circument operation conditions of solar system with the peak shaving and valley filming character of ternary lithium iron phosphate, zinc bromide liquid flow, and all vanadium radix flow batteries. So also we have different manufacturers from here, and all from the world-leading manufacturers like Huawei, like Sungrow, and we just comparison their products and their performance in this area. So we have 4 types of batteries. They're all the mainstream batteries around the world. And for the last part is the overall performance comparison area. So in this area, we just covering special module comparison as well as new equipment and materials demonstration comparison. We have special modules including PID restined monocrystalline silicon module and modules made of self-cleaning materials, modules with different junction box and different backsheet materials, and different EVE modules. So that is the first test base in Shanghai. This is also the first test base of HHDC. Based on this and based on the experiments we achieved in this test base, we just have the second plan of the second demonstration base. So this demonstration base is located in Daqing. So this is the map of China. So the last impractical test base I mentioned is in Qinghai, which is the northwest of China, and this test base is located in this part of China. So they have, you can see the longitude and the latitude of this. This have very cold temperature, and you can see the cold and temperature and the climate. It's have very extreme climate. So we just wanted to see that in this kind of temperature and the climate, so how of this equipment and this energy storage equipment, their performance, we want to just testify this and to comparison the performance of every new products around the market. And it have flight land. So this is also a 2 gigawatts. It's a 2 gigawatts solar PV and energy storage in practical test base. So it's very huge and it's have a high latitude. So we can see that in this kind of situation, what will this performance will be. So this test base have 4 major junctions. The first is basic and core in practical functions. So this is the basic and main functions of the platform to carry out the outdoor in practical test for PV and energy storage products. And we want to carry out in practical comparison with laboratory data and manufacturer's data. So we just, you see that all the data from laboratory and manufacturers, this just data that they offered. So we just also want to testify the truth and the truth of their data. So we just comparison all of the equipment in this test base. And the second junction function of this is expanded in practical function. So on the basis of product in practical test, outdoor experiments are conducted on new technologies and latest products of PV and energy storage. We just want to promote the technological innovation and industrialization, promotion, and application. So the third function is the public and open testing function. So we can openly facilitating testing products and solutions for PV and energy storage for various objects such as designers, developers, manufacturers, etc., and according to the needs of the industry under the guidance of the relevant authorities to provide testing service. So the fourth function of this platform is the market recognized certification function. So on the basis of the continuous improvement of the impractical experiment function, we can enhance the market recognition, seek the support of relevant national management departments promote the testing and certification of solar and energy storage products in due course and create a market-recognized solar and energy storage product standards. So we just mentioned that we have cooperations with many world-known companies and departments like Fraunhofer solar institutions and Japan institutions, such etc. like that. So the platforming planning is planned uniformly, implemented by stage and complete in 5 years. So about in this platform, there are about 140 impractical test schemes were planned and arranged, and the converted cell is about 1.05 gigawatts. At least 100 impractical test schemes are arranged every year to carry out a demonstration, experiment, detection, and certification for new technologies, new products, new materials, and new design schemes. So we are SPSC, and we are the largest solar operators around the world. So we have good connections and relationships with many manufacturers. So we want to test for the new technologies, new products, and new materials every year, and to promote our company's innovation strengths. So each year, 6 impractical test comparison areas are set up according to the technical progress of the year. Each area adopts the unified zoning coding principle. The number of each area is like that, first 1, first 2, representing the impractical test area. So we are just gonna introduce the phase 1 of this platform. So in the first phase, there are 6 comparison area and 161 demonstration experiment schemes. So there are 4 product demonstration areas. There are photovoltaic module, inverters, mounting structures, energy storage products. There are 2 system demonstration in practical area, that the photovoltaic system and the energy storage system. So the demonstration base is divided in 2 parts. The smart management, we have smart management and display platform, and the field system, the PV module, inverters, mounting structures, energy storage products, PV system, and the energy storage system. So this platform was approved in December 2020 and starting construction in April 2021 and starting operation in November of the 2021 and started in practical work in January 2022. So as for now, we have some achievements already. So for the demonstration and testing scheme, we are conducting hundreds of market researchers and technical exchange with domestic and foreign equipment manufacturers, scientific research institutions, testing institutions, industry associations, and held more than 20 program demonstration meetings and experts consultation meetings. So for the module area, we have 29 modules from 40 manufacturers. So like Longji and Ingli and many of this kind of manufacturers. And technical routes, we have like PERC modules and TOPCon modules and HIT modules, IBC modules, and for their size, they have this kind of size. And for the inverter area, we have 10 different inverters from 6 manufacturers, and we have centralized inverters, distributed inverters, and string inverters. So for the comparison, we think that string inverters have the better performance. So as for the mounting structure area, we have 21 different kinds of mounting structures from 7 manufacturers, and we have the design and testing schemes like 66. So we have different type of mounting structures, like fixed structures with different angle, and different structures with regulable angle, and flexed single axis mounting structures, inclined angle axial mounting structures, and vertical single axis mounting structures. And for the energy storage products, we have 8 types of batteries from 7 manufacturers. There have lithium ternary, lithium iron phosphate, and all vanadium redox flow, lithium titanate, and different. These are all from the mainstream of the batteries in this market. And for the energy storage system, we have compared 6 kind of different energy storage system schemes, like hybrid energy storage system and a singular battery energy storage system. As for the solar PV system, we have 42 kinds of solar PV system schemes. And for the scope of this in practical test form, and there are as follows: the demonstration and in practical of equipment combines vertical and the pie-node comparison, and vertical verification on whether the impractical results of the equipment in different outdoor application scenarios and operating environments meets the indicators and the parameters guaranteed by supplier. So the parallel verification and comparison on the real performance of each equipment in different application scenarios and operating conditions. So as for the modules, we compare the measured power efficiency, degradation rate, temperature characteristics, spectacle characteristics, and weak irradiance performance, mineral aging characteristics with laboratory data, as well as the power generating characteristics in different application scenarios and different type weather conditions of modules in the outdoor conditions. For the inverters, we just compare the measured efficiency and PBT tracking efficiency, overload capacity, IGBT operating temperature, and fault duration, fault power loss, start time, power equality, etc. And for the mounting structures, we compare the outdoor impractical power generating characteristics and irradiation characteristics, backside reflectivity, power loss due to the accumulated snow and dust, LCOE, etc. And for the battery energy storage system, we just verify the applicability of different energy storage technologies in serve cold and high latitude regions, and including the cell voltage consistency, temperature coherence, battery DC system efficiency, battery system efficiency, attenuation rate, circle counts, depths of discharge, and lucid power consumptions, etc. And the solar PV in practical test area focused on the solar generating system was tested on the overall integrated performance of different modules, mounting structures, and inverters under the real operating conditions. And the BSS in practical test area is equipped with solar plus BSS power generating system with 100% solar PV and energy storage equipment, which could meet the peak and frequency regulation demand of the power system. So for the solar PV system with all the equipment as the basic comparison elements, and by researching and verifying various combinations of different modules, inverters, and mounting structure, so we see that the actual operating conditions and parameters test of the solar system are carried out to verify the performance indicators of the equipment under various operating conditions in the real site. And the BSS system, we can through the joint control of the solar and BSS system, the solar power generating characteristic, as well as the active support and output regulation capabilities of the equipment can be improved so that the solar plus BSS power station could be self-regulated and safer and stable, so which have we can fix the problem of the PV power plant, the unstable problem, and we can guaranteed become one of the main power supply resources for the new power system, reducing the rotation reservoirs capacity of power system and realistic peak and frequency regulation on power supply side. So we have some research on the African market, like some of the Africa countries like South Africa, they have many situations like their electricity always be cutted, and some of their enterprise like the manual enterprise. So this is have bad influence on them. So they want to build their self PV power plants. But if we all know that like this kind of enterprise, this kind of company, they want a stable electricities, stable power supplies. So the PV power plant or the wind power farm is not enough for them. This due to the solar resources and wind resources, it can't supply the stable powers, and for their manufacturers. So there comes to the energy storage plant. So maybe the PV power plant plus energy storage is their first choice for their company. And we also searching for this kind of opportunities because our company is have rich experience in the not only in the PV power plant, but also the energy storage. So we can see that the PV power plant plus energy storage, we can just having the stable power supplies. And this is also, I think, is also the trend of the future. And for the test equipment, we have 7 categories, 19 types test data, and we can decide into resources, electrical performance, environment, and the mechanical properties. We can see that this is both the photograph on site on our test base. So we can have 1 main and 2 unnecessary public weather stations, 1 main weather stations and 2 weather substations, installing meteorological equipment such as all-sky camera equipment, irradiometer, UV irradiator, spectrometer, automatic solar tracker, crystalline silicon reference buffers, etc., to collect and analyze the solar resources and environment of the platform in real time. And for the real-time online measurement device with the online IV tester, temperature sensor, and the crystalline silicon reference buffers, inverter monitoring box, power meter, etc. These equipment are installed on the modules, sync box, inverters, and the box transformer respectively to realize the real-time monitoring and analysis of the whole system and loss of each section from module to box transformer PV power plant throughout the day. So we have the following test methods, the combination of online and offline and lab testing. The online test system is mainly used. The offline test and the lab test are combined to achieve mutual collaboration of the accuracy and the complementary testing. The second is the combination of public test and special test. We just lay out of public test equipment to ensure the consistent test data and according to the data analysis needs of each comparison area layout corresponding special equipment. And the third method is the consistent test conditions. We're using a uniform stand setup, ensure the consistent test boundary conditions and the representatively test data. And the fourth test method is the test data continuity. The required test equipment is determined based on the data analysis needs and designed with redundancy to ensure the data continuity. So you can see the lab test equipment in your lab, and this is the inverters inside the inverter side window. And this is an online AV tester, and this is a portable AL tester. So for the data collection and the cleaning, so the source of data, all data comes from the high precision test equipment and system installed on the platform, and the test equipment is regularly collaborated by the third-party authority to ensure the accuracy of the collected data. the frequency of the collection. So the frequency of the data collection is in second, and the clock of all test equipment are standardized to ensure the consistent data time. And we used their hold judgmental zero draft test, data judgment, horizontal data comparison, multi-dimensional data verification, etc. We can judge and ensure the validity of the data. So for the data analysis, we have a special group for this analysis. We just established more than 40 analysis models such as irradiation, temperature, spectrum, backside irradiation radio, attenuation, etc., and more than 150 automatic analysis reports, and the real-time data collection, real-time online analysis, and automatic generation of analysis reports. So for the third part, the achievements that we have in this test platform. So the first one is the empirical result analysis. So we have different application scenarios, like different reflect temperature scenarios, different typical weathers, the sunny, cloudy day or windy day or snowy days, and the 24 dimensions. The contact was analyzed in combination with the empirical test comparison area and conducted empirical data comparisons, output 462 comparison data in total in the first quarter. So for the module empirical test area, we have empirical analysis of power, temperature, voltage, power generating, and other characteristics. We just formed 134 performance index charters, and we have different technical routes of modules, different size of the cell modules, and different versions of modules. And for the inverter empirical test area, the empirical analysis of inverters efficiency, temperature, overload capacity, start-stop time, the power generating, and other characteristics. And we just formed 42 performance index charters. And we also have different technical routes of inverters and different manufacturers. For the mounting structure empirical test area, we just comparison the irradiation, occlusions, immiscibility, and power generation and other characteristics from the 152 performance indexed charters. As for the PV system in practical test area, we just operating current, power, inverter efficiency, start and the stop time, power generating, and other characteristics. We have already formed 104 performance index charts. And that's all some of our achievements, the empirical results report. So we just having these achievements and these empirical data in this test form. So we want to share with others with our results and the reports. So we have detailed empirical experimental technical results report. It's just have quarterly, semi-annual, and annual reports. And we have externally published reports on the result of the empirical experiments. And we also have produced special empirical data analysis report for different users needed. And for the meteorological empirical results, the percentage of backside irradiation at different heights. So in the horizon 4-row arrangement, irradiator heights from the ground like 1.6 meters, 2.5 meters, 3.4 meters, and 4.3 meters. The percentage of the backsheet irradiation of each row was 40%, 50%, and 50.85%, and 50.09%. There were difference in the percentage of backsheet irradiation of each row at different heights from the ground. So you can see that they are 1.6 meter from the ground, and the irradiation amount will be like 469.07, and the have different results. So we can see that the module operation temperature and the operating voltage. This is the data and the different voltage and different type of modules, the operating temperature of the modules of different size is not very different, and operating temperature of 210 size module is the slightly higher. So we can see that which one have the best performance. And the operating voltage of different size of modules in the low temperature environment in the first quarter is higher than the normal voltage. And for the inverter efficiency, we can see that the inverter efficiency of different technical routes is more than 89.5%, which is basically consistent with the manufacturer's laboratory data. So the inverter efficiency of the string inverter is slightly higher than the centralized and distributed inverters. These results are all based on the on-site data. And for the mounting structure in practical result, we can see that the power generating and the irradiation of fixed mounting structure at different space. So the increase of the spacing of sub-areas help to improve the power generating of per megawatts of sub-areas, and the power generating per megawatts after increase the spacing by 0.8 meter is 2.68% higher than that by decreasing the sub-area space by 1.6 meters in the first quarter. For the backsheet irradiation and the proportion of backsheet irradiation is different at different spacing. The larger the overall spacing, the higher the proportion of backsheet irradiations. So for the PV system in practical results, the theoretical calculations and actual measurements. So the difference between the measured backsheet irradiation gain of the mounting structures and the theoretical backsheet irradiation gain is large. With the large-scale application of tracking mounting structures, a set of software for calculating the power generations on the back of tracking mounting structures should be developed. The power generating of fixed mounting structures at different heights from the ground. So when the distance above the ground is 1.6 meters, like this one, the power generating is the highest. You can see that exceed the 40.57%, and which is the power generating in the highest is the 1.6 meters, and which is respectively like 0.05 and 0.452% higher than that at the 1.4 meters and the 1.2 meters. So the irradiation of fixed mounting structures at different heights from the ground, this is also the results, and the minor difference of front side irradiation with different heights. So larger difference of backsheet irradiation with different heights, the lower the height from the ground, the smaller the backsheet irradiation and the lower the backsheet irradiation ratio. So this is the solar system. This is the solution for different type of mounting structure combinations. You can see we have single axial mounting structures, fixed mounting structures, vertical mounting structure, bifacial vertical, integrated single axial and fixed, integrated single axial fixed and adjustable. So you can see these are different performance of the different mounting structures. So the solutions for different type of mounting structure combinations are as follows. So we have different power output curve of the combined solutions. The combined solution lead by fixed mounting structure. The result is the parabolic curve with single peak. The combined solution lead by flat single axis with tracking. The result is saddle-shaped curve with double peak. The combined solution lead by dual axis with tracking system. The result is a flattened parabolic curve. The generation increased by 20% and the max peak power output increased by 50% compared with the fixed mounting structure. And the combined solution with different mounting structures in the same area. The result is the flattened parabolic curve with single peak of flattened saddle-shaped curve with double peak. The generating increased by 3% and maxed peak power output reduced by 9% compared with the fixed mounting structures. So the fourth part and the last part is the future perspective. So this is the irradiation map of the Africa continent, and we can see that in Africa, so there are good resources, enrollment, and great development potential. You can see that there are highest irradiation in South Africa continent, and the South Africa countries are rich in light resources, and the wind countries, as for the countries who have sea around it, like South Africa, they have extremely good wind resources, and we think and South Africa also have great development potential on this renewable energies. We can see that because we have also having some development on the overseas market. So we just did a lot of research on the global renewable energy market. So we can see that there are certainly large projects in Europe or in any other countries, but there are only some countries like the Middle East, the MENA region, and the Africa regions have this potential to build the huge renewable energy projects. So they have great potential in the Africa continent. So the African Union countries are rich in the land resources, and the scale of the power of the project can be considered to be 100 megawatts level, and thus providing a professional field in practical platform for the African Union countries. And we think in practical experimental platform can focus on the world's most advanced photovoltaic technologies and verify it in the African Union countries, which is of great significance. So you have the rich resources, and you have the rich in land resources, and we see the great potential in the South African countries to develop the new renewable energy projects. So, and we also know that many African countries have launched their renewable energy plans. So like Egypt, they have 2013 visions of the Egypt, and we also said that the Algeria is launched the biddings for the renewable energies, and even also the Ethiopia, there have, and the Morocco's. We also know that Morocco, they have plans for the renewable energies, and even for the green hydrogen plans. So we all know that besides the energy storage technologies, the new trends of the world is the green hydrogens. So we also know that some of the African countries also have their plans for the green hydrogens. This is the trend for the world, and for some countries like China, we have the carbon neutralities and the carbon peak visions. So we think that green hydrogens and the Africa have also one advantages in transportation. It's have the shortest distance within Europe with the largest off-taker of the green hydrogens. So we think that Africa is a great potential in developing the green hydrogen projects, like Morocco's, like South Africa's. We already heard of their plans to develop this kind of renewable energy projects and the green hydrogen plants. I think for our company, we have the technical adventures and the staff adventures, because we have so many expertise on this, on the photovoltaic, on the wind farm development, and even on the energy storage technologies, and even for the green hydrogens. So we think there are huge potential for us to cooperate in this great opportunities. So we can see that the significance of developing in practical test form in the countries League of African Union. So we just suggest we can build demonstration projects in the African countries or regions recommended by the African Union. We can just cooperate to promote the research on the regional photovoltaic technology innovations. And the research result of the demonstration projects are well representative and replicable in the African Union countries and regions. So through a long-term test and inspections, the system application comparison and research are carried out on various products, equipment technologies, and economic indicators to promote the improvement of technical products, optimize design, guide equipment selections, improve efficiency, and reduce investment cost. So that is the significance of developing this in practical test platform in the countries in the African Union. So that's all for my today's presentation, and thank you for listening. So
thank
I
you
also,
very much.
yeah, thank you. I also listed
No.
my email on the below. So if you have any questions, I'm much honored to communicate with you.
Okay, no problem. We'll definitely communicate with you. Thank you very much for this very good presentation, and it gives us really very important and useful information on how you do the test of storage. You know, when we talk about renewable energy, I think the main element is the storage. If you have a good and powerful storage, definitely you will get most benefit of the renewable energy product. So we have some comments in the chat, but also we'll have some participants online who will make live comments. So some of the comments that I have online is, for example, what are the differences between photovoltaic power generation system and solar energy power generation system? I think someone asked this question yesterday, but after the first two presentation has finished, so he could not get the answer. And the other question maybe that we may need from your presentation, there is a question that if the empirical tests that you perform are according to international standards, or they are according to a developed standards, meaning that you develop your own procedure and standards and you are doing the test against those procedures. The other question maybe that we can ask in this first round is whether you tested the combination of solar and BESS for only energy arbitrage. What was the main reason of test having the combination of solar and BESS why did you do the combination for? Was it just for energy arbitrage? And maybe the last one, your intervention, do you work with the private sector or you work with government only? Meaning the project that you install in different countries, you mentioned Dubai, Niger, in Sahara. So these projects are they you work with the private sector or you cooperate with the government only? So Madam Cousin, let me put this first question first, then I will get some additional question from the floor. So if you can just give some information about this one first. Thank you so much.
Okay, thank you for the question. As for the first question, using this meaning of the combination with the solar PV and energy storage. So we think that, as I already mentioned in my presentation, because the solar PV and wind power like this kind of renewable energy, they have some disadvantages. So they are so rely on the resources. So if they are in the sunny weather, so they have stable power supplies. But if there are cloud just shading the PV panels, so this power supply just becoming very unstable. So we just having this energy storage system, so we can just to fix these problems. For the solar PV, solar PV, they have unstable problems, and energy storage with the solar PV and with wind, we can see that the power supply will become stable, and that's the meaning of this. They can give you the stable power supplies. So that's the main meaning of this combination of these two technologies. So in our companies, we also have some hybrid technologies, like we have solar plus wind plus hydropower hybrid technologies. So we you know that our company is started with the hydropower. So we have many large hydropower stations, and the PV power stations is not very far from the hydropower stations. So we just come up with this plan. So we just come up with this technologies like the solar hydro hybrid projects. So maybe like in the afternoon, so the sun's resources is very good. So at this time, we just using the PV power stations to have to offer the power supply. And when the sun goes down and the PV stations cannot supply some stable powers, then we just using the hydropower stations to fix this. So this is also the similar with the PV power plants plus the BESS system. So that's the main meaning of this. And for the another questions, I think so. So you just mentioned that because we as HHDC is a state-owned company, so are we not only cooperate with the government? So this is not true. We just open for all kinds of cooperations. So like we already have projects in Saudi Arabia. So we just partner with the Saudi Arabia's Aqua Power, and the but I think we just open to every kinds of companies. We just happy to cooperate with the governments, and we are just happy to cooperate with the private companies. So as long as we are just gonna to develop the renewable energies in Africa, so that we are open to all the opportunities. Thank you.
Thank you so much. Now I'll give floor to some of the participants to also ask some question. I will first give the floor to Marcus, then I will give it to Loco Maxime, and then Lucas Magero. So Marcus, you have the floor. Marcus. Hello, Marcus, are you still with us? No. Okay, now let's move to Loco Maxime. Loco Maxime. Loco Maxime.
Oui, bonjour à tous. Bon, je n'ai pas de questions particulières, non.
Ok, baissez votre main dans ce cas. Monsieur Bangali Jakite. Bangali Jakite.
Allô?
Oui.
Vous m'entendez?
Oui.
Ok, merci beaucoup. Je remercie beaucoup l'Union africaine et le gouvernement chinois pour avoir, n'est-ce pas, organisé cette formation et dans le cadre du renforcement des capacités des agents de l'énergie de l'Union africaine. Bon, moi, ma question, c'est par rapport à la planification. Comment vous planifiez, n'est-ce pas, la maintenance des centrales photovoltaïques? Merci.
Okay. We'll take an additional question before we give the floor to Shusen. Samsung. Samsung. Mr. Samsung, no? Okay, let's move to Michel Oudraogo.
Ok, merci. Merci pour la brillante présentation. Donc, ma question porte sur est-ce qu'il est attendu que cette structure soit une structure de certification pour tous les fabricants de modules photovoltaïques, d'onduleurs et de structures. Donc, quand on va payer prochainement, ou bien quand on va faire une commande, prochainement, on devrait pouvoir, est-ce qu'il est attendu de voir cette société stampiller les équipements pour nous permettre de dire que voilà, ce sont des bons équipements. Donc ça, c'est la première question. La deuxième question, c'est par rapport aux tests qu'ils ont eu à effectuer pour les batteries, pour les différents matériaux qu'ils ont eu, lithium, tous les matériaux qu'ils ont utilisés. Est-ce qu'ils peuvent conseiller, nous, en tant qu'utilisateurs, quelle est la batterie qu'il faut choisir pour ses meilleures performances? Merci, madame, pour votre présentation encore. Merci.
Merci beaucoup. I will give the floor to another person. I think Samsung. Samsung, can you unmute? No. Okay. Lamine Ouattara. Lamine Ouattara.
Allô, vous m'entendez?
Oui.
Bonjour à tout le monde. Lamine Ouattara de la Côte d'Ivoire. C'était pour d'abord remercier Madame Kering et remercier encore l'Union africaine avec la coopération chinoise. Et nous, en Afrique, ici, on a vraiment besoin de ces genres de communication sur les systèmes solaires. Alors, ma question est la suivante. Chez nous, ici, en Afrique de l'Ouest, précisément en Côte d'Ivoire, le système éolien n'est pas développé. Alors, quelle est la démarche à suivre pour essayer de détecter dans un premier temps les zones propices à cet éventuel système pour que nous puissions nous intéresser et pencher vers le système éolien de Ronava. Voilà un peu ma préoccupation.
Ok, merci beaucoup. We will give the floor to Madame Tuzen to try to address this question before we take maybe another round with the 2 or 3 additional questions. Thank you so much.
Okay, so thank you for the questions. And as for the first questions, so about the O&M, the plan of the O&M. So as for our company HHDC, we have a we have a O&M team and O&M company for a very we have just have more than 10 years of the experience in the O&M, and we also have the advanced technologies like AV tester and the drones. We use drones to test for the whole power plant, and we also set up a bunch of standards and procedures for the O&M of the power plant, and we also we have more than 10 years experience in the O&M, and we just having the daily O&M, and we have a detailed plan for the daily O&M and the O&M for like 1 week, 1 month, and 1 quarters and 1 years. We both have some detailed plans for this. And for the second questions, so you were asking, so which kind of batteries have the best performance? So as for these questions, based on our research, we found that the best performance of chemical energy storage batteries, the chemical energy storage batteries have the best performance, and the main popular or the lithium iron phosphate and other chemical energy storage batteries. So of course, some other type of batteries are also being developed and produced. So, but as for our side, we think the chemical energy storage batteries have the best performance. And for the last questions, so you are in the west of Africa. So we think, because I'm sorry, we didn't do many research on the West Africa especially. So we just did a research of the whole area of this Africa continent. So we think Africa has, but this reminds me of some kind of opportunities some other companies just offered us. That's in your countries. That is a solar PV projects, and I think that's not maybe 100 megawatts, or I can't remember very precisely. I think in West Africa, the irradiation and the resource of the solar is very good, and you can thinking about to develop these kinds of projects like PV power plants, and the PV power plants with plus the energy storage projects. I hope that answers your questions. I think West Africa is also full of potential on the renewable energy projects development, because there are many Chinese companies and some European companies. They are also want to develop the renewable energies, and they both have their plans and their strategies. And I think like EDF, like Enel, like our company SPIC, and even for some Saudi Arabia company like Aquapower, they both have strong strategies and plans in the Africa. So I think this is also an opportunity for both parties. So you have the resource and you have the land, and maybe other companies, they have the technologies, and you can see this is a win-win cooperations. You can combine the combination of the two parties, and they have in win-win projects.
Yeah, thank you very much for those brilliant answers. I will take another round of questions. I will start with Nana Konde, then I will move to Samsung, and then I see Lamin Ouattara. I don't know if he wants to speak again, but let's take Nana Konde.
Oui, merci beaucoup, monsieur. Bonjour à tout le monde. Merci, madame, pour la présentation. Ma question, c'est au niveau du stockage de l'énergie. Est-ce que dans les centrales hydroélectriques, on peut faire stockage? Ça, c'est ma première question. Et comment, si c'est bon, si on peut faire le stockage dans les centrales hydroélectriques, et comment peut-on le faire? La seconde question, les centrales hybridées, comment on peut procéder aux différents stockages? Je vous remercie.
Je ne sais pas si les autres vous entendent, moi, je n'entends pas. OK, Mr. Samsung. Samsung, can you speak now? Lucas? Lucas?
Good afternoon.
Yeah, good afternoon.
Okay, my questions was based on the previous presenter, but I'm very happy to get this chance so that I can ask my question. I could like to know what could be the percentage of renewable energy mix in grid connections with other source of energy, such as hydro, gas, and the coal. But the second question, what could be the life operating times for the solar power plant?
Okay, thank you, Mr. Lucas. Maybe let's try Kipsa Isaka. Kipsa Isaka.
Oui, ok. Bon, oui, bonjour, je peux? Vous m'entendez?
Oui, allez-y, allez-y. On vous entend.
Ok, merci bien. Merci bien en tout cas pour cette présentation qui est vraiment la bienvenue. Donc, j'avais deux questions. La première, c'est liée donc aux technologies de stockage. C'est quel type donc qui a été donc déployé par l'entreprise, notamment est-ce pour la régulation donc de fréquences et de tension pour les réseaux, ou bien c'est pour le report de charge, c'est-à-dire donc la fourniture d'énergie donc en période de pointe en général donc observée par nos sociétés d'électricité. Et la seconde partie donc c'est quel partenariat donc ils envisagent avec l'AFREC, y compris donc les autres institutions telles que le WAP ou l'AREC en matière donc de régulation donc sur le réseau interconnecté. Merci bien.
Merci beaucoup. La dernière, on va prendre Siham. Siham, do you want to put forward your question? Okay, then we'll give the opportunity to the presenter to address these questions. Yeah, please go ahead. I think there was one question for Mr. Liu on, I don't know if he's still online, asking what could be the energy mix percentage of renewable in a grid connection with other sources like coal or hydro. But I mean, if Madam Kuzen can also answer this question, that is fine. Madam Kuzen, you have the floor, please. Thank you.
Okay, thank you. So as for the first questions, it's also a question about the PV and energy storage. So the combination of energy storage and photovoltaic, it can store the actual electricity that generated during the day and generate electricity at night. So it can also improving the quality of the electricity. And as for now, the cost of the energy storage, it's about $0.27 US per watts. So, and well, let me check the questions. I'm sorry.
No problem.
Another gentleman asked how to choose different energy storage methods. So our test base, we collected numerous energy storage data, and we can approve like which kind of energy storage methods are more efficient. And if you are interested, and we can support you the data, and this data are including about the qualities of the electricity and the efficiency of the electricities. So if you are really interested, you can contact us, then we can provide you this data. And next question is the PV power plant. The PV power plant usually in the power purchase agreement, it's about 25 years, but actually the life of the modules now it can achieve like 35 to 37 years of the quality insurance. So as for now, we can say that 30 years is fine. And another question is, as for the renewable energy can access to the main grid, and we can just use the energy storage to adjust the quality of this electricity, the powers, and so we can have a totally off-grid renewable energy projects. It's available, and another gentleman also mentioned, is that okay for the renewable energy plus like thermal power or the hydropowers? Yes, that's for us. Technically, it's all work for us. So we now our company, we have the PV plus wind power, and the plus hydropower, and the plus thermal powers. Yes, that's all work. And for the grid connections, we can cooperate with another enterprise like China State Grid. Yes, that's something like that. We can cooperate on this part. So I hope my answer is fine for you.
No, you did it very perfectly. I think that brings us to the end of today's session. I think it was very interesting, helpful. I can see everybody really pay very special and good attention to what is being said, and so I didn't see anyone really who is complaining. I know there are other questions that people want to ask, but because of the time, we have to stop here. But we'll continue engagement with the SPIC HHDC later on. So we'll continue engaging with them on how to benefit from their experience. We will definitely work with them how to set up a testing center in Africa, and why not a manufacturing center, so that we can also be able to manufacture a storage system and also build a very good system. So it's a long way, but I think we are having a very good start. As I said, we will really design a very comprehensive capacity building program, definitely with the support from our colleagues from China, and we'll be having an action plan for maybe. For now, we can have an action plan for 5 years that we will be implementing, and we will do assessment how this plan has been beneficial for the people. So with that, I would like to end today's session here. But definitely, I invite you for tomorrow. It's a continuity. We will still have our colleague from SPIC tomorrow having two good. Excellent presentation before you tomorrow. The first one will be on the integrated smart energy system. So we'll have another presentation on module 6 on the integrated smart energy system, and the module 7 will be on new energy storage, hydrogen production. So I invite you to be available tomorrow and to come to continue this training journey. So if you have other questions related to storage, please keep your question. We'll try to answer them tomorrow. With that, I thank very, very much Mr. Liu and Madame Kuzen for their brilliant presentation and answers that they provided to the participants today. We'll continue engaging with them moving forward. I thank you and have a good afternoon, good evening in China.
Thank you so much. Have a nice day.
Thank you. Thank you.